Alright, welcome back. So in the previous course we could see that the symbol of a DC power source, which was a battery in our case, looked like this. Actually, there was another symbol that we used, such as this one, and now you might wonder what's the difference between the two? Well, the actual symbol of a battery is this one, while the other one represents a battery cell. The difference between cell and battery is that a cell is a single unit that converts chemical energy into electrical energy, and a battery is a collection of cells. So a single AA battery, for example, that outputs 1.5 volts is made up of one cell. A 12 volts battery, for example, has 6 single cells in series, producing a fully charged output voltage of 12.6 volts. Anyway, people usually use these two symbols interchangeably, both producing a constant DC output voltage. What is a DC voltage in the first place? Well, DC, which stands for direct current, is a bit easier to understand than alternating current. We will look at alternating current as well in a minute. So a DC voltage, rather than oscillating back and forth, DC provides a constant voltage and current. Remember that DC is defined as the unidirectional flow of current, so current only flows in one direction. Voltage and current can vary over time, so long as the direction of flow does not change. Now let's try to visualize the flow of current in our simulator. Alright, so we have a DC voltage source that outputs a voltage of 1.5 volts. Of course, you could change the output voltage of the source by just double clicking on it and rewriting this value to the one you want. And we have a resistance in this closed loop circuit to prevent causing a short circuit between the two leads of the voltage source or power supply, you name it. Now, if we want to visualize the shape of the output voltage at a certain point in the circuit, so let's see the voltage that our voltage source outputs, just right click on it and click View in Scope. So as you can see, our voltage source outputs a simple constant voltage of 1.5 volts. This unchanging positive DC voltage causes an electrical current to flow in one direction. I know we didn't talk about current yet, we will discuss about it in more detail in the next course, but for now let's just focus on the direction of these tiny yellow dots that represents the current. So notice that the voltage difference between the positive lead and the negative lead causes electrical current to flow in one direction, coming out from the positive lead and going towards the negative lead. Well, this might be confusing for a beginner. In reality, electrical charge, or simply current, moves from the point of low potential, which is the negative terminal, to the point of high potential, which is the positive terminal. So actually the current should flow in the opposite direction. Now, when electricity was discovered for the first time, scientists thought that it was the flow of positive charges that generated electricity. This theory went on for quite a long time, hence even when it was correctly discovered that it was the negative charges that actually flowed, the scientists decided to keep considering the same theory of positive charges flowing. So the conventional direction of electricity is opposite to the actual directional flow of electricity. As a result, conventional flow of electricity is from the positive terminal to the negative terminal in a circuit. Great, more on this later. Alright, so both AC and DC describe types of current flow in a circuit. In direct current, the electric charge only flows in one direction. Electric charge in alternating current, on the other hand, changes direction periodically. The voltage in AC circuits also periodically reverses because the current changes direction. Let's see this behavior in the simulator. Here we are. Now notice that the symbol of an AC power source is different from the one we were used to. There's a little sine wave in there which indicates a time-varying waveform, with the most common of all being called a sinusoidal waveform. Sine waves are by far one of the most important types of AC waveform used in electrical engineering. The shape obtained by plotting the instantaneous ordinate values of either voltage or current against time is called an AC waveform. An AC waveform is constantly changing its polarity every half cycle, alternating between a positive maximum value and a negative maximum value respectively with regards to time, with a common example of this being the domestic mains voltage supply we use in our homes. Now we won't go into how AC voltage is generated or how AC voltage is transmitted over wires and then reaches your home, or how is AC voltage from the mains converted into DC. That's an off topic right now. I just wanted to show you that compared to DC voltage here, electrons change direction periodically. So when the voltage is positive, the current flows in the clockwise direction. And when the voltage goes negative, the current flows in the opposite direction. Yes, you heard it well, voltage can be negative, but that doesn't mean that minus 10 volts is lower in energy than a positive 1 volt. The negative sign of the voltage indicates that the current flows in the opposite direction. If all looks complicated at first, don't worry, because as we progress, you will get a good understanding of how these things work.